The definition: a quadratic is an expression, an equation, or a function of the second degree, or if you like, of degree 2, because the highest power of the variable here is 2. So what is an expression, what is an equation, and what is a function? An expression is a combination of numbers, variables, and mathematical operators. By mathematical operators, we mean our addition sign, our subtraction sign, our multiplication sign, and the division signs. Those are the mathematical operators. So, an expression does not carry an equal sign. So, the one that satisfies the definition of an expression here is the first in line. So, this is what we call the mathematical expression. It is just a combination of numbers A, B, and C, variables, the variable x, and the mathematical operators, addition sign, subtraction sign, multiplication sign, and the division sign. An equation, on the other hand, carries an equal sign, and it is equated to a real number. In most cases, this real number is the number 0. So, an expression does not carry an equal sign. An equation carries an equal sign. That is the major difference between an expression and an equation. Expression does not carry equal sign. Equation carries equal sign. Now, the next one in line is the function. Now, what is a function? A function is closely related to an equation. But the difference between an equation and a function is that an equation is equated to a real number, like I said, in most cases, 0. But a function is equated to another variable. So it means that in this function, we're having two different variables. The variable x, the variable y. So, more comprehensively, it is written as y of x. That's to tell us that y is a function of x. And the expression defining this function is ax squared plus bx plus c. From an expression, it can be translated to become an equation. Also, from an expression, it can be translated to be a function. So these two are the functions. A function can be written like this simply, or more comprehensively, or something like this, telling us that y is a function of x, and the expression defining this function is ax squared plus bx plus c. We move on to the forms in which quadratics appear. Forms of quadratics. Quadratics can appear as monomials. By monomials, we mean either a single term expression, or a single term equation, or a single term function. A single term expression appears as ax squared. The squared must be there because that's what qualifies it to be called a quadratic. The variable is x, and the coefficient of x is a. Don't forget, that a will be a real number because it says a, b, and c are real numbers. The coefficient of x squared is a, the coefficient of x is b, and the constant is c. So, quadratics can appear as monomials. And examples of monomials can be maybe 2x squared, 7x squared, minus 5x squared, 18x squared, and the list goes on and on. So these are examples of monomials. The coefficient of x squared here is 2. The coefficient of x squared here is 7. The coefficient of x squared here is -5. The coefficient of x squared here is what? Is 18. So these are quadratic monomials in expression form. Now, if these monomials are to be turned to equation, then you are going to introduce your equal sign, and after the equal sign, you put the real number. So once there's a real number after the equal sign, it becomes an equation. The real number can be 0 or any other number, but like I said, in most cases, the real number it is being equated to is what? 0. So those are quadratic forms in which quadratic appear when they come as monomials. Binomials are two-termed expressions. Two-term expressions, and binomials can be in this form: ax squared plus bx, or ax squared plus just the constant c. And these expressions or these equations or this function can appear in this format. Let's say 3x squared plus 11. In this case, the variable is still x squared. The coefficient of x squared is 3. That is representing a here. And the constant is 11, representing c here. So if quadratic binomial can appear in this form, it can also appear as probably 3x squared minus 5x. This form follows this format. This form follows this format. Quadratic binomial, quadratic binomial. It can also appear as minus 8x squared plus 11. The list goes on and on. Again, as we have them. So the coefficient of x squared here is negative 8, and the constant is what? 11. The constant can be any other number as it comes to my mind. That's how I'm putting them down. So this can be plus 12, can be plus 17, can be minus 13, as much or as they can come. So, but the main target we're after is that they are binomials. What are binomials? Two-term expressions, two-term equations, two-term functions. Don't forget that these are all expressions. You convert them to be an equation by introducing your equal sign and your real number after the equal sign. The same expression can be transformed to be a function by introducing another variable, maybe y of x. So that y of x will become 3x squared plus 11. Y of x will be equals to 3x squared minus 5x, as the case may be. Sometimes they may use f of x. That's to tell you f is a function of x. This one is saying y is a function of x. So those are binomials. Then by trinomials, we mean three-term expressions. They have 3 terms, and that is the complete set of this as we have. So we are going to be having ax squared plus bx plus c. In this case, all the terms are complete, and this is what we call the standard form of a quadratic, or standard form of what? Quadratics. Now, it can be standard form of quadratic expressions, standard form of quadratic equations, standard form of quadratic what? Functions. So that's what maybe the standard form, starting from the highest power of x squared and coming to the one without any variable with it, which is what we call the constant c. So examples of quadratic binomials can be 2x squared plus 5x minus 13 is a quadratic trinomial, or minus 16x squared plus 2x plus what? 8. That's also a quadratic trinomial. Or x squared minus 5x plus 6. This is also what? A quadratic trinomial. Or x squared plus 7x and then plus 10. Also a quadratic expression or a quadratic trinomial. So in each case, we can see that there are 3-term expressions. The coefficient of x squared here is 2, the coefficient of x here is 5, and the coefficient of, the constant is what? Negative 13. Here, the coefficient of x squared is 1, the coefficient of x is 7, and the constant is positive 10. So these are forms in which quadratics appear. So we have talked about the quadratics, definition of the quadratics, then types of quadratics being an expression, being an equation, being a function, then forms in which quadratics appear. So we'll look into factorization of quadratic expression, which involves us breaking down a complex term into what? Simple terms. Factorization of quadratic expressions. Welcome back. Now we are on factorization of quadratic expression. Now in factorization of quadratic expression, there are different forms in which the expression can come. The first one we are looking at, which we tag section A. It says the leading coefficient A is equal to 1. What do we mean by that? You know that the coefficient of x squared here is equals to 1, because in every quadratic expression, equation, or function, the leading coefficient is the coefficient of x squared. That's the leading coefficient. So the leading coefficient here, which is A, is actually equals to 1. And if you look at this expression, you see that x squared does not have any number attached to it, does not have any number attached to it. So if it's not having any number attached to it, it means that the coefficient of x squared is what? Is 1. And the coefficient of x is 7, and the constant is 12. All right, so when we have situations like this, the coefficient of x squared is 1 directly. We spring to action without any premeditated or pre-work needed rather. Now, we look at the coefficient, we look at the constant. The constant is 12. We look for the factors of 12. What do we mean by factors of 12? In pairs. Any two numbers such that when you multiply them together, they will give you what? 12. So those are what I mean by factors of 12 in pairs. So the factors of 12 in pairs are 1 and 12, because if you multiply 1 and 12, they are going to give you 12. 2 and 6. If you multiply 2 and 6, they'll give you 12. 3 and 4. If you multiply 3 and 4, they will also give you what? 12. I think these are all the pairs that we can have by addition. Then the factors do not stop here. Then we can have -1 and -12. Because -1 times -12 is still going to give us what? +12. Because we're looking for the factors of +12, being a plus here. We have -2 and -6, because -2 times -6 also will give us what? +12. And then we have -3 and -4, because -3 also times -4 will give us what? +12. Now, these are all the factors of 12 in pairs. Now, let's add these factors together. 1 plus 12 is going to give us 13, positive 13. 2 plus 6 will give us positive 8. 3 plus 4 will give us positive 7. -1 plus -12 will give us -13. -2 plus -6 will give us -8. And -3 plus -4 will give us -7. So we call this one the sum of the factors. Sum of factors, whereas these are the factors in pairs. Now, which of these are we going to use? We look at the middle term here. The middle term, which is the coefficient of x, is 7. That's 7x rather. And the sign for 7 is positive. So we have positive 7. So which of these ones, this sum, give us positive 7? Of course, this is the one that gives us positive 7. And the numbers that produce positive 7 are positive 3 and positive 4. So we use this plus 3 and plus 4 to reproduce 7 in this expression. And the expression can now be rewritten as x squared plus 3x plus 4x and then plus 12. The reason being that 3x plus 4x is going to give us 7x. And then 3 times 4 also give us what? 12. So we say these factors of 12 in pairs, the one that gives a sum of 7 is this, or are these two, and we use those two to reproduce 7. That is what we do. We don't just use any number anyhow. It must satisfy this condition. Two numbers whose product is 12, and their sum is what? 7. So what is the next thing to do now? We try to separate them into two brackets. Open the first bracket, put x squared plus 3x in the first bracket. Close it. And immediately after the closure, put a plus sign and then open another bracket. The sign here is plus 4. So plus 4 is the same thing as a ordinary 4x, and then plus what? 12. So what we have just done is that we put this first two in one bracket and this last two in another bracket. That's what we have done. Now, what is common to x squared and 3x? Of course, the x is common. There is common factor in there. So x squared divided by x will give us x, and then plus divided by plus here will be plus. 3x divided by x also will be what? 3. Now, what is common to 4 and 12 is also positive 4, and that's going to be plus 4 bracket open. 4x divided by 4 will give us x, plus divided by plus will still give what? 4 plus rather, and then 12 divided by 4 will give us what? 3. Now, a careful look at this expression, you will see that x plus 3 is in the first bracket and x plus 3 is in the second bracket. So we say they are like terms. They are exactly the same thing. So what do? You pick only one of them and open a bracket on that. So you put x plus 3 in that bracket, taking only one of these. Then you open another bracket. Outside this bracket, we have x, and outside this bracket, we have plus 4. So with this, you have successfully factorized the expression x squared plus 7x plus 12. That's question 1. Question 2. Write x squared minus 9x plus 20 as product of their factors. As before, the coefficient of x squared is 1. So it means that the leading coefficient a is equals to 1. So proceed. We look for the factors of 20 in pairs, and they are 1 and 20, 2 and 10, 4 and 5. Those are all the factors in pairs by their positives. Then we have negative 1 and negative 20, negative 2 and negative 10, negative 4 and negative 5. For each of these pairs, if you multiply them, they always give you positive what? 20. 1 times 20, 20, 2 times 10, 20, 4 times 5, 20, negative 1 times negative 20, positive 20, negative 2 times negative 10, positive 20, negative 4 times negative 5, still positive 20. So the next thing is to find their sum. Sum of 1 and 20, 21. Sum of 2 and 10, 12. Sum of 4 and 5, 9. Negative 21. Sum of negative 2 and negative 10, negative 12, and negative 9. Now, of all this sum, which of them give us the middle term, which is negative 9? Of course, it's negative 4 and negative 5, rather, producing negative 9. So we are going to reproduce negative 9 as x squared minus 4x minus 5x plus 20, because negative 4 times negative 5 will give us positive 20. The negative 4 plus negative 5 will give us negative 9, and then negative 9x. So the next thing now is to put them into two separate brackets. So open the first bracket and put x squared minus 4x, close the bracket. Then immediately after that bracket, put a positive sign, plus sign, then open a bracket, the second bracket, and then put the next two. This is minus 5x, so it's going to be written as minus 5x plus 20. Then we look at the first bracket. What is the common factor or highest common factor between the two terms in there? The highest common factor there is x. So x squared divided by x will be equals to x, plus divided by minus here divided by plus rather will be minus. 4x divided by x will give us 4. So we have factorized the first bracket. We look into the second bracket. Now, what is common to negative 5x and positive 20? We can say 5 is common, yes. Now, if we say 5 is common, we are going to have to say negative 5x divided by positive 5, because if 5 is common, that's positive 5. Plus divided by minus here. Sorry, minus here divided by plus here, rather will be what? Minus. And that's going to be what? Minus x. But if you look at what is inside the first bracket, it is what? A positive x. So definitely we are supposed to bring out what? Negative 5 from this bracket. So that minus divided by minus will be what? Plus. So we already have a plus x here. So minus 5x divided by minus 5 will be what? Plus x directly. Then plus divided by minus here will be what? Minus. Then 20 divided by 5 will be 4. And by that step and that process, we can see that what is inside the first bracket is exactly the same thing as what is inside the second bracket, just as we have it here. So what do we do? Open a bracket and pick only one of these two brackets. That's going to be x minus 4. The first bracket, close it and open another bracket. Outside here is x, and outside here is what? Minus 5. So it means that we have been able to factorize this expression, or to write the expression as product of its factors. It means that x minus 4 is a factor of this expression. X minus 5 is also a factor of this expression. Just as 1 is a factor of 20, 4 is a factor of 20, 5 is a factor of 20, 2 is a factor of 20, 10 is a factor of 20. So what do we mean by factors? Factors are smaller numbers or smaller entities that can break into a bigger entity without leaving any remainder. 2 can divide 20 and it gives a quotient of 10. That's a result of 10 without any remainder. Negative 4 can break into positive 20 and it's going to give us negative 5 without leaving any remainder. So factors are smaller entities that can divide a larger entity, leaving no remainder. So I believe with this, we've been able to deal with factorization of quadratic expression, especially if the leading coefficient is what? A is equals to what? Minus 1. The only one we have not done is that, you see, the factors that we have considered so far, they are positive factors because we have positive 12. We look for the factors of positive 12. Then, positive 20, looking for the factors of what? Positive 20 also, and then their sum. So the next set of examples that we're going to be looking at are constants that have what? Negative sign, negative constant, like negative 20, negative 12, negative 6, negative 10, negative 18, and so on and so forth. Stay tuned.